department, and he has graciously agreed to do a seminar for us, all right, on active learning. Now, just a little bit about Mr. Glew here. He's the Director of Postgraduate Programs at Aston Professional Engineering Center, Aston University, School of Engineering and Applied Sciences. If you saw the abstract that I sent over email, you would know the contents of the talk for today. Yeah, basically, it's going to be focused on active learning. Now, Mr. Glew comes with tons of experience, and I think there's a lot we can learn from him today. And from what he told me just now, he likes debate. All right, so feel free to ask him lots of questions. Okay, so without further ado, I'd like to pass the session to Mr. Glew.
Thank you very much.
Thank you.
Thank you. Yes, I do like lots of questions. I like a lot of debate. Can you hear me all right without using the microphone? This comes from having worked in the steelworks for a while. Before the days of earmuffs and everything, you just had to shout. So I'm quite used to doing it. Also, when I'm lecturing, I like to be able to wander up the back from time to time so that the students start to worry about what's he doing. Is he looking at the notes that I'm scribbling and things like that? It keeps them on their toes, keeps them awake. Anyway, so thank you very much for that introduction, and thank you all for finding time to come to talk with me today. And I hope it will be a talk, a two-way thing. If there's anything I say at any stage where you want to interrupt me, please do. I don't believe in this putting your hand up and waiting to be asked a question. Just shout out and say, we are peers here, for heaven's sake, after all. So let's get started. I've chosen what I hope is an interesting title. The role of active learning in an Industry 4 world. I'm assuming that some people will have heard of Industry 4 and possibly some others haven't. So the idea, that's a hook to get people who probably haven't heard of Industry 4 to come along and say, well, what's this all about? Well, we'll touch on that, but the essential content of what I'll be talking about goes back to before the start of Industry 4. And I just realised that when Industry 4 came along, there was relevance here. So I'm trying to adapt what I'm doing to a catchy title, which will get interest. Now, it's a truism to say that it's an old cliche to say, shall I say, that the world is changing around us. We could have said that any time in the past 300 or 400 years and it would have been true. But it's also true to say that it's changing faster today than it's ever changed before. And so we have to respond to that. It's more noticeable, the rate of change, so we have to respond to that. That's true in industry, it's true in society. Education, in my experience, tends to lag a little bit behind. And perhaps that's a weakness in our education system. So what I've tried to do is to stimulate change. Sometimes I've gone a little bit further than perhaps I should, to try and drag recalcitrant colleagues along with me. But that's what the basis of this chat today will be about stimulating change in HE. Tell you a little bit about Birmingham and where I come from. Who is this guy? Why is he coming to talk to us? To give it some relevance, well, I'm from Aston University, and that's in Birmingham in the second. Some of you will probably be aware of this, but maybe not. We're right in the centre of the UK, which is great with excellent transport and communications. But we're not down in London where all the Imperials and all those people are. We're about halfway between Oxford and Cambridge. Maybe that's true in more than just geographic terms as well. We're probably halfway between Oxford and Cambridge. We're neither one or the other. We think we're better, but they would disagree, of course. Birmingham was the cradle of the Industrial Revolution, as it used to be called. It's where a lot of it started. Not everything. You could argue the Stockton and Darlington Railway up here, or the Liverpool and Manchester Railway, and the cotton mills around Lancashire. But the real heart of industry, steel-making factories, already started around Birmingham, what we call the Black Country, for the very obvious name that it was very black, smoky around there with the factories. The world's first steam-powered factory is only a couple of miles away from our university. So we have a long heritage of working with industry, and we've built on that. This bridge, the world's first iron bridge, which still stands, again isn't far away from us. You can still walk across it. It's no longer available for road transport, but you can still walk across it. That's how far Birmingham's industrial history goes back. Nobody can talk more about industrial history and industrial experience than people from Birmingham, and Aston is in Birmingham. So, but we're also a modern city. Now this is a picture which sort of shows that difference between the very old church and the very new shopping centre, what's known as the Bull Ring. Called the Bull Ring. It's nothing to do with Spain or bullfighting, but it's called the Bull Ring. I should know why it's called that, but I don't. So it's a very modern city in lots of ways. It's got a lot going for it. I'd hope some of you will come and visit us one day. You'll have a lovely time. It hasn't got the greatest reputation, but when you're actually there, really nice people, really great food, very exciting nightlife, and some stimulating intellectual activity in the universities. Around us also, we are also the centre of the high-tech automotive industry. The overwhelming majority of Formula One motor racing teams come from within 50 miles, 75 miles of Aston University. This was effectively Industry 2, the growth of the motor industry in the UK. Okay, Henry Ford started it over in the States, but in the UK, it really started around Birmingham. We still have an enormous number of automotive manufacturers and component suppliers around Birmingham. Unfortunately, most of them are owned by international companies, Chinese companies, German companies, Japanese companies. There's very few owned by British companies, but they have been taken over by particularly the Germans and the Japanese, and they're doing very, very well. Jaguar Land Rover, one of the most successful companies since it was taken over by Tata. Huge renaissance in that. And all the Formula One teams around there. So we've got this nice mix of the old and the new that gives us that perspective on time and what's happening with change. We're a university since 1966. We are in the top 50 under 50 universities in the world, I think 45 or something like that. But we have a long history. We go back to 1895 when we were set up as a technical college. We're still relatively small, only about 10,000 students, which is small even by UK standards. It's very small by global standards. I'm not sure, I have been told how many there are at UTP. What have you got at the moment?
Yeah, about 8 plus.
About 8 plus, but you're growing fast, aren't you? And your target is somewhere around about 20 or something? Something like that. I seem to remember being told that at some stage, but you're growing fast. Yes, because it's difficult to be small in today's world. It's very difficult to achieve ranking positions when you are small. But we are punching above our weight. We're not high in world rankings. We're somewhere in the top, it varies from ranking to ranking, somewhere in the top 300, depending which year we look at it and which tables you look at. But we're certainly punching above our weight. We're one of the smallest universities to be in that ranking, apart from the very specific universities. We do have world-class teaching and research, but in very narrow areas. We've got a really established reputation for industry-focused programs and employable graduates. Our graduate employment rates are better than Oxford and Cambridge. And that's not what we're saying, that's what independent audits are showing. We haven't got time to go into the detail, but that's a fact. We have 5 schools. Aston Business School is probably the most well known. It's a triple accredited school within the top sort of 20, 30 in the world. I'm not sure what their ranking position is, but we also have Life and Health Sciences, Language and Social Sciences, Engineering and Applied Science, which is my school, and who I was here in May with my Executive Dean as part of this first possible collaboration with UTP. And we have recently started up a medical school. That's not really kicked in yet, that will kick in next year. In terms of world-class research, European bioenergy research. This is something which I think might be relevant to our partnership with UTP. Bioenergy, of course. Europe at 15 million quid invested only a couple of years ago in this new centre, which is based in Aston. But it's not the only, this is in engineering, by the way. That's not the only one. We've got 3 other areas of really, I wouldn't say they're all world-class, certainly photonics and EBRI are. Systems integration research and engineering education. We are some of the best in the UK, if not Europe, certainly in engineering education, and we were just discussing that. Systems integration is just being set up. This is really interesting though, because it's all about big data. So this is effectively Industry 4 that we're coming onto. So we're not wide, we're deep. We've got the depth rather than the breadth. The School of Engineering, has a number of disciplines. We don't cover everything. Chemical engineering, computer science, electrical engineering, maths, mechanical engineering design. All these are discipline specific. My group, my centre, it's not a group, we don't have a head of department. This is innovative and novel. All of these have a professor as a head. We don't. We're multidisciplinary. My dean puts up a diagram of our school with 6 circles around, and in the centre, all of those are groups with a professor and associate research and organisational administration. We're in the centre. We don't have a head of department. We work with all the groups because we're multidisciplinary. This approach that we're adopting is about the thinking skills that engineers need at whatever level they are and at whatever discipline. So we work with all the disciplines. 2000 to 2010 was been a significant time of change for HE in the UK. It's been a lot of expansion. The government previously had a plan to grow HE expansion to participation rates to 40%. With hindsight, that's a no-goer, and it's been pulled back, and I don't know what we are at the moment, but I think we'll be lucky if we get to 25 to 30%. That's still a large percentage of the population going to university, and that's very expensive for doing 3 or 4 year degrees. But on top of that, of course, there's a changing graduate employment market. There is far greater emphasis these days on employability of graduates, because there's far more of them, because they are being designed to go into the world of work. That's what the government wants. They want a large percentage of population going to university because they want to become a knowledge economy, because there's more added value there. We can get greater GDP per person. So there's far greater emphasis now that universities have got to turn out employable graduates, and I'll come back to this shortly. UK's role has changed very much in a global economy. Yeah, we're very much a service industry economy, but manufacturing surprisingly still is a very large percentage of our economy. We're still something like the world's 7th largest manufacturing economy. That's not in terms of, it's not because of volume, it's because of the high added value. Very expensive goods, very expensive medical equipment, very expensive aero engines, very expensive missiles and things like that, and cars. So there's not a lot of it, but what we make is very expensive. And that's where Aston kicks in, because our employability, creating engineers. All of this has changed a difficult balancing act for UK universities. To maintain the quality, but to have an adaptive content from what we used to do to what we're doing now, we've got to do it to far more people, and we've got to drive the costs down, because the government's been cutting back. And that's not, I mean, it's a time of change, but it's always been a time of change, but that's what we've been struggling with. The league tables, what's going to happen looking forward from 2010? I'd say 2010 because that's when I started with Aston. So that's when this sort of project I'm working on started. League tables have changed the concept of HE. We are now very much more thinking about the students as customers. They pay the fees now. There's very little subsidy for universities from the government. All our money comes from fees, and the students are now thinking of themselves as customers. They want what they're paying for. They pay a lot of money for this. So that's a real issue for us. We've got to keep the students happy. We just can't tell them to go away anymore. We have to respond to their needs. If we don't, somebody else will. And the significantly higher fees in 2012 has reinforced that. As a result of that, universities have invested an awful lot of money in major facilities, but these are usually associated with making the students happy. Better accommodation, better sports facilities, those sorts of things. And that's been a drain on resources. It's limited the amount of money we've got to spend on staff and on educational facilities. So what we've seen as a result of that is that there has been a squeeze in the middle range. There's been an expansion of the top-end universities who've been able to grow and build on their reputation, and there's been an expansion of the numbers going to the universities at the bottom of the league tables who are charging a lot less, because students who are concerned about borrowing money will go to the cheapest universities, and so there's been a squeeze in the middle. And Aston is at the top end of the middle. But we are coping with this. It's been difficult, and we are expanding, but slowly. I think it's a truism to say universities are not yet businesses, and they probably never will be. But we have to act more business-like in the way we respond to the pressures being placed on us. we're having to become a lot more like them than we used to be. We developed a strategy, say we, I had nothing to do with the strategy, that was at the Vice-Chancellor level, but to be the UK's leading university for business and professions, where original research, enterprise and inspiring teaching deliver global impact, with targets for league table positions, research, all the sorts of things that every university has. However, when I've gone through this, I think actually we're very closely, I don't know how you've come across this book by Ehring, University. It's an interesting read. It might be something that you want to get a copy of and have a look through. Changing the DNA of higher education from the inside out. And basically the story goes along the lines of, yeah, there's lots of pressures on us. Now what do? Do we respond to those changes incrementally and ad hoc, try and keep the customer satisfied, industry happy, governments happy? Or do we sit down and radically rethink what the role of HE is from the people who should know best about it, which are the people who are working in HE? We're very lucky in HE, we've got a great job. This academic freedom which has been given to us doesn't exist in any other line of business that I've ever worked in. This ability for us to influence how we do things, usually we're just told. So maybe we should take the responsibility of that and respond to it and actually start to say, well, what do we think as academics should be the role for universities going forward, rather than have it imposed on us. We can all criticise and complain and say we don't like the changes, but they're going to happen anyway. If we can lead, maybe we have a chance to influence how we are going to look like in 20, 30 years' time. So that's an interesting read. So I've gone through that. So my position as a result of all that thinking, and this is my own personal position, this isn't the position of my university or even my centre, but it's where I'm coming from. What's my passion? Why am I travelling the world doing all this sort of thing all the time? Because I believe the world needs millions of young engineers, creative, dynamic professionals for the 21st century. You know, the world's problems aren't going to be solved by engineers from the existing university system. It's not big enough. We just can't cope with it. The problems the world faces in the next 100 years are going to the problems from the past 100 years are going to pale into insignificance to the problems in the future. Who's going to resolve those problems? Well, of course there'll be a role for politicians, but it's not going to be a big role because they're in it for the short term. Engineers are usually in it for their life, for their career. So, you know, we're the people who've got the expertise to develop the technical solutions to solve the problems of the future. But to be greatest respect, it's not going to be us in this room doing it. It's going to be the engineers who have learned from us, who are our students who will do it. So that's our objective, to pass on to them the skills and abilities to do for that. And they won't come from the normal existing system of higher education because it doesn't give them the right mix of skills. The existing higher education system is basically a paradigm from the 1600s. You know, if we had a time machine and we went back 400 or 500 years ago, there wouldn't be that many differences between where we are now. There'd be some. Obviously, we wouldn't have this, yeah, and we'd have a microphone, but we'd have about a 1.5 hour discussion session in a sloping room with people sitting in rows, with somebody sitting at the front. You wouldn't have the iPad, you might have a quill and ink, but basically the system of education, one person talking to a group of others, hasn't changed for many hundreds of years. Yet everything else, nearly everything else about industry and our social life has changed, but education hasn't. I don't think the existing system is good enough to cope for the 21st century, and it needs to change, and that's what Eyring thinks as well. And they also won't come from the old Western developed economies of the 20th century. Yeah? I mean, what are the numbers? Just look at the numbers. The UK and Europe and the USA, we're just not going to be able to produce those millions of engineers. Where are they going to come from? They're going to come from Aston, they're going to come from China, they're going to come from India, they're going to come from South America and Africa. If we want millions, that's where they've got to come from. People in the UK don't want to be engineers. People in the UK want to be actors and actresses. They want to go on TV and things like that. They don't want to do engineering, it's dirty. But over here, this part of the world, and in Africa and South America, I find people still want to be engineers. They see the value of it. So what we have is we have a great education system. We've developed it since the Industrial Revolution. I think we know a lot about it. We need to work with the rest of the world where these young engineers are going to come from. And that's our obligation. That's what's driving me. That's why I think I want to do this rather than just work towards my pension. Now, how does this fit in towards Industry 4? Well, I've started all this exercise, and then I've read about this Industry 4. Come out of Germany, I think the first reference to it's in about 2011. I don't know if you've come across it before. And it's this group of people who said, look, let's look at these the significant changes, the breakthroughs in the way the world has operated. And we've had what we call the Industrial Revolution. Then that was fine for about 200 years. Then we had the first production lines, Henry Ford and people like that come along. That's changed the nature of production. Then comes along programmable electronics, programmable computers, those sort of things came along in the 70s. And now what they're saying is the world is changing again because of cyber-physical systems, the Internet of Things, all of these sorts of things. And this is going to change the way the world works. And what's interesting, like just about everything in life, you'll see the exponential rate of growth of change. So this is where we are now. Now I've argued when I was back here saying that the existing system wasn't good enough. Now that we're getting into this, it definitely isn't going to be good enough. We've got to respond to that. Now, all of these sorts of things you'll have seen. These are the basic elements of Industry 4, and you'll find them anywhere on the internet. Some of these I know a little bit about, some I know nothing about. I know a little bit about additive manufacture, because we've had some of that, rapid prototyping and things in the university. I don't know if you've got rapid prototyping equipment here. We've got big data analytics at the university. One of my colleagues runs the research department there. Obviously, I've got some of my students at BMW who are working on autonomous robots. I know a little bit about that, but I know very little about most of this. Certainly not enough to stand up and say I'm good enough to be an educator of engineers who are going to have to deal with this stuff. Okay, so am I redundant in that role? No, I don't think I am, because what I do know about is the way engineers think. And I believe that the way engineers think is consistent, rather than what they think may change from time to time, but the way great engineers think is the same for each discipline. The way engineers acquire knowledge, the way they evaluate knowledge, the way they synthesize it and put it together, it's the same whether you're a chemical engineer, a mechanical engineer, an aeronautical engineer. What you think about is different, but the way they think is pretty much the same. And if we say our educational courses are not just about what people know, but how they know what they know and how they use what they know, then I think I've still got a value to be able to talk to people about these sorts of topics. And that's basically what these courses that I'm trying to develop are doing. Industry 4 then will need engineers who are multidisciplinary and multi-skilled. They need to be creative, because a lot of these things the staff in universities know very little about, but the engineers going into it will need to know about them. So they're going to have to create their own knowledge and understanding. They have to become self-learners. Have you heard of this Mode 1 and Mode 2 knowledge creation modes? By Gibbon et al. Is an interesting book, which I've got a copy of. I can give you the details for. It goes back quite a few years now, but Gibbon and his colleagues said, look, going back to this model of technical rationality, which has driven the university sector for so long, is that knowledge was created in the universities and it was then passed down to industry to use. That may have worked 50, 100 years ago. It's not working now. Far more knowledge is being created in a non-structured way, in messy, multidisciplinary, complex environments in industry as it's happening. But we're not necessarily capturing it. We are producing hundreds of thousands, millions more papers every year in referee journals. Most of them are never read. There's vast amounts of knowledge being created by academia, which is being produced for the benefits of academia. It's not necessarily being produced, some of it is, but it's only a smaller percentage, and it's a shrinking percentage, is being used by industry. A lot of knowledge, when I was working in industry, when we had a problem, we didn't go to a university to solve it, we solved it ourselves. And that's what's happening with Mode 2. There's a lot more knowledge being created outside universities now than inside universities. Our graduates in the future need to be entrepreneurial. They need to be confident enough to use those entrepreneurial instincts, and they need to have a global perspective. And I don't believe, and yes, we all go to say in our courses, we all aspire to create these sorts. Of course we do. No one's going to sit around and say, well, I'm not going to create a creative engineer as a result of my course. I'm not going to create a but we don't do it well enough for the future needs of Industry 4, I don't think. And I think we need to. The challenge is that, is that these are the problems that's going to face the 21st century. This is the content of a typical engineering degree, isn't it? What's the link between them and solving these problems? Do we talk about that link? No, we don't. We say, generally speaking, that's what we deliver, that's what the world needs. How's that going to be bridged? Well, maybe Industry 4 is a mechanism for bridging that gap, for taking this. And I don't know, but working with colleagues like yourself here and in the rest of the world, maybe we can find a way. So what is the purpose of education? How are we going to work on that? So there's lots of ways of looking at this, asking this basic question, what are we about? Preparing the young for citizenship. I think that's fair enough. That's, let's be general about it. Preparing people to participate in the economy and the world of work. Yes, that's certainly become more important in the UK. As I say, it's all about employability skills. So I accept that one. To make the world a better place. Is that too naive to suggest that's what we're here for? I would certainly like to think so. As you get older, as I'm getting older, that one becomes more important to me. That one was most important when I first started, then that one. This is what matters to me now. I want to leave a changed world for my children, my grandchildren. Education is one of the most powerful instruments for reducing poverty and inequality. The world suffers horrendously from poverty and inequality still. That's unsustainable in a world where everybody has a mobile phone and can see how the other half is living. They're going to resent it. But education is a tool for solving that problem. And that's not me saying that, that's the World Bank. And another guy I've got a huge amount of respect for, Professor Ken Robinson. He was Professor of Education at Warwick Manufacturing Group. He's actually now an honorary professor at Aston University. His view is that education is multi-personal. Personal, cultural and economic. Yeah, fine, that's great. There are 6 billion people plus. So we have 6 billion plus versions of personal. It's cultural. There's a few thousand versions of culture around, so our education systems has to be able to be capable for 6 billion people, not higher education, but it has to accommodate a few thousand versions of cultural structures. And economic. But there are only going to be a few versions of economic paradigms in the future, one of which will be Industry 4. We'll talk a little bit about more of those potential versions of economic structures in a minute. Another guy I've got an awful lot of time for because he stood out and said what he believed in, Martin Luther King. The function of education is to teach one to think intensively and think critically. That's the word I latched on, to think critically. But education which stops with efficiency may prove to be the greatest menace to society. I so agree with that. The vast majority of education in the UK over the past 20 years has been about efficiency. Get the numbers up and keep the costs down. How efficient can we communicate the knowledge and understanding of our lecturers into our students? That's what the league tables measure, that's what exams measure, that's what technology is being used for. You know, why are we recording this lecture? So it can go out for more and more people, rather than just a few who's here. Let's make it more efficient, record it, use technology to put it on the internet, more people will see it. It's about efficiency. It's not necessarily about effectiveness. Of course we want it to be effective, but the primary driver for the people at top of universities who are chasing the students, chasing the money, is efficiency. Students bring money. He also said, intelligence plus character. That is the goal of true education. That's a good handle. I worked on this. When I read that, I thought, how can I work on that? How can I interpret this for my aims? So I looked at what both Ken Robinson and Martin Luther King said. I said, look, I've got this little model. I love diagrams because I'm an engineer. We like diagrams. Pictures are far easier to communicate with. So we've got these three zones of education, and intelligence and character. This is where it overlaps. Can we combine the two together? A little divergence on intelligence. Have you heard of the Flynn effect? Anybody come across that? Nothing wrong with saying no. No? Okay, the Flynn effect. I hadn't until a couple of years ago. I went to listen to this lecture by James Flynn. I got an invite to this lecture at Cambridge by Professor James Flynn. I thought, oh, what's this about? The flyer said about... So I read up about it, and I went, and it was really fascinating. James Flynn, very charismatic character. He's been looking at the data on intelligence testing over the past 100 years, and what he's almost without any doubt been able to demonstrate, there's always doubt, obviously, in any, is that the level of intelligence of the average person has been increasing over the past 100 years. And it's very much a straight line. This is the data. He's done masses and masses of data, because there's, of course, there's an awful lot of doubters about that, but he's worked on it for years and years and years and produced this, what's called the Flynn effect. He didn't call it the Flynn effect, somebody else called it Flynn effect later on. And that's interesting. And he says that the reason for that is because our thinking tools have changed. It's not because we're becoming cleverer. It's because the tools that we think with has changed. It's a bit like saying, go back 200 years ago, if you had looked at how many bullseyes could a gunman, a soldier, hit a target. If they could get one a minute with a muzzle-loader rifle, that was the target, that was good. But if you then looked 50 years later, you might get half a dozen because you'd gone to a barrel loading. And then if you look later on, another 50 years, you'll be getting hundreds because of machine gun. It wasn't because the people were getting better at shooting, the tools of shooting had changed. And what he's saying is this improvement with our intelligence has become because our tools of thinking have changed. Now I haven't got time to go into that, but I would certainly steer you to the brief videos, a 20-minute video. It's one of the TED Talks. Have you heard of TED Talks? It's one of the TED Talks is on there, which is interesting to start, and then you can go and get one of his books if it interests you more. But the interesting thing from my point of view is if we extrapolate that line, it can't have been this, can it? It just can't have been that going back in time. Otherwise, 200 years ago, our ancestors would have had virtually no intelligence at all. How could they have created the Industrial Revolution here with an IQ of 20? It just wouldn't have happened, would it? So it must have been, the graph must have looked something like this. Yeah? So if it's curved there, what's going to happen next? Is it going to keep going up? Is it going to be a straight line? Or is it going to curve down again? Now I don't know. If we take Flynn's idea that it's about thinking tools, the thinking tools, are we going to be able to keep creating new thinking tools or not? Like the way we create new robots and new software and things like that. Or are we going to be able to accelerate it? Well, I don't know. I don't know whether James Flynn knows. But we are here. What we're looking for is Industry 4 in the future. What's going to be the intelligence of how are we going to capture that? Are we going to be able to keep that intelligence line going? So that's just a sort of diversion which I might like to steer you to. But employer engagement. So what are we going to do about employer engagement? Mass participation, even if we think of mass participation as only being 20–25%, is still going to be unsustainable unless higher education create wealth to support the costs of mass participation. When we were in the UK and we had 4 or 5% participation in higher education, it was fine. The state could afford it. People could afford it because there was a few rich people getting the benefit on the back of all the people working in the factories. 4 people spending 4 years out of their life at university was absorbable. A working life, typically 40 years of work, maybe a bit more, 45, 50. If you take 4 or 5 years in education, you take 10% of your working capacity away. If half of the population do that, then that's 5% of the production capacity has been taken away. Can the other 95% of that production capacity support that 5%? I don't think it can. I think there's more pressing demands for that 5% in terms of poverty reduction, health, and those sorts of things. So education is going to have to start creating wealth. If we're going to get to 25%, we have to create value from that operation whilst we're doing it. If we can do that, then we can be sustainable. Wealth is generated by employment systems. Yeah, we can create it by digging things out of the ground to some degree, but most of it is created by employment systems. So in the future, higher education should focus as much on employment skills, as on intelligence and character. So yeah, I think what Martin Luther King said was great about intelligence and character, but I want to supplement it. When he was saying it back in the 60s, or was it the 70s, I can't remember, this was what was driving him. What's driving me is that's valuable, but I think it's got to be as much about employment as well. So I've now got 3, so I've modified that. Whether you agree with me? Now if we look at employment systems, what sort of employment systems do we need? Well, the World Economic Forum model identifies three economic models that economies go through. There is factor-driven, which is basically digging things out of the ground, farming, those sorts of processes. This is all about. There's efficiency-driven, which is making things, and then there's innovation-driven, which is what most of us call the knowledge economy. And they plot, you come across this flying geese model of development, where economies move through these, and as they move from one to the other, the efficiency-driven is cascaded down. It's what's happening in China. All the manufacturing is leaving China now as wages go up in China, going into Vietnam and Philippines for manufacturing clothes and electronic goods and things like that. I would imagine, and you tell me if I'm wrong here, I think the UK is just about in here at the moment. I would imagine Malaysia is somewhere on the borderline. I don't know. What do you think? Are you yet in? You aspire to a knowledge economy, but is the vast majority? What's the bulk of your economy? Is it about manufacturing? There'll be some factor-driven, obviously, with digging stuff out and getting, well, drilling holes in the ground to get stuff out. Yeah. So on average, where is it? Well, but each of those pillars of economics, they call it, there are the basic requirements. This is the World Economic Forum model again, saying the pillars for a factor-driven economy are institutions, infrastructures, these sorts of things. But for efficiency-driven, higher education and training is vital. So higher education is really important to get the most of an efficient-driven economy. And certainly, although it doesn't say so, it's implicit as that is a foundation for that, higher education for innovation and sophistication factors for innovation-driven economies. So there are different types of economies. Different levels of employment skills are needed for each of these economies. So we have to start to evaluate what is the context of our higher education system. Is it in a factor-driven, an efficiency-driven, or an innovation-driven economy? It's not for anybody else to tell you that. So what are the intelligence and character skills that we need for the employability types for each of those economies? Well, we normally talk in terms of employability skills, and I'm sure you do, in terms of hard and soft skills. That's not something you're very familiar with. Hard skills, technical qualifications and technical competence. Soft skills, personal skills you might call it, management, communication, teamwork and thinking skills. So this is what the universities talk about, so let's adopt that model. What are they? The skills needed by graduates to help them get a job. The skills needed by graduates so they are useful employees. The skills needed to maximise their potential. There's three ways of looking at employability skills. From a university point of view, it's usually about that. Graduates come to university to get a qualification, to get a job. They don't want a qualification so they can put a poster on a certificate on their wall and look at it. They go to get a qualification so they can get a job. So that's what they need. But once they've got a job, what is it the employers want? Employers don't want to take graduates who they then have to spend another 6 to 9 months training before they're useful, and yet a lot of employers say that's what they have to do. Criticising universities constantly for not giving them employable graduates. So for employability skills, they're saying it's hitting the ground running. From our perspective, as educators, I would have said that's more important. I don't know whether you agree with me, and if you disagree with me, say so. But I would have said employability skills are the skills necessary to maximise any individual's potential throughout their life. That's what really interests me. I'm not interested in getting a job or helping the employer. I'm interested in helping society, helping people. So the technical model, there's this model of technical rationality sort of says this is basically what happens is universities will deliver the hard skills. Higher education will deliver hard skills. Soft skills, nothing to do with us. We're disciplines. You know, what drives us is our discipline, right? So we don't really like that. This is a model which I struggle with, but it's a model that's actually quite interesting because it's got this nice sharp point. And to me, that's this little model I use. The sharper that point, the more likely that is going to go through getting a job barrier to employability. We've got to have a nice sharp point to break through that barrier. The engineers with the sharper point are going to get through that barrier quickest. The engineers with that sharpest point are going to be the ones who get the most from their career. We need to have both. We cannot just have one or the other. The employability skills development, therefore, is an important part of what we've been doing at Aston. It's something that we're well known for in the UK. I said at the start, our employability rates are higher than anybody else's in the UK. Well, there's 2 or 3 other universities are better, but we're better than Oxbridge and most others. What have we been doing over the past few years at Aston to develop that? Well, we've got employability skills embedded within the academic curriculum. I mean, you can add them as add-ons or whatever. But we've done this. We have this CDIO, which was mentioned in the flyer, conceive, design, implement and operate. For our full-time students, we said what we're going to do, more so than anybody, 50% of our second year's time is spent doing projects. We've cleared the basement of the university, we've set up a big laboratory, all the engineers get together in big groups and we give them projects to do. Have we got internet access here, by the way? I've got a short video I'll show you about that. Other universities adopt the co-curriculum, and we do a bit of that, where we say the academic curriculum stays as it is, but we will add on the employability skills by industrial placements and employability skills courses. That's another, we do it as well, but we think that's best. This is what I do, academic learning within the world of work. I said, those are tinkering. This is radical. Let's put the academic learning into the world of work, so they run concurrently. Just see if this works. Don't have a lot. Okay.
Try cancelling it.
No? Okay. Well, it's obviously conscious of the time, and I talk for far too long anyway, so I don't know. But it's about 20 minutes of video altogether, which takes you through all the CDIO activities, which are for the full-time courses, and Aston is very proud of. We're part of this CDIO initiative. Now, most of the CDI people around this part of the world are from technical colleges, but that's because they're vocational and they see the value. It's not that this CDIO doesn't apply to level 6, level 7, it does, and we've shown how important it is. So don't just dismiss it because most of the people doing it are polytechnics and technical colleges. Glew as a high-profile university, look at how you can use this CDI technique at level 6 and level 7, which is what we've done, and we've shown you can do it. Those videos will give you the indication of the success there. Oops, I'm going to go out to that now, then, don't I? I'm going to go to the next one. So what I'm saying is these soft skills that we're trying to develop have to be appropriate to the level, whether they're primary employability skills, intermediate employability skills, or higher level employability skills. They have to be individualised, they have to be dependent on the factor of which pillar of the economy you're at, whether you're at factor-driven, efficiency-driven, or innovation-driven. It's a complex, messy business. Sorry, I just said that. A different mix of employability skills will be required at the various stages of economic development, at the various stages of education and employment, and by various sectors of the economy. So it's a messy mix. So trying to say that we can put every graduate through the same program of developing employability skills, I think to me is a waste of time, because we're forcing everybody through the same die when they're all going to need different programs. So that's where CDIO scores over some of the co-curriculum developments. So the problem is, and why do we still got this problem, is that we still got this skills gap. We're still getting people who are coming out of university who haven't got the correct skills, and yet we are producing graduates who can't get jobs. We've got employers on one hand and saying we need more graduates to fulfill the skills gaps, and yet we are putting people through at university, 20–30%, and we've got a very high level of graduate unemployability. And it's a dichotomy. How can that occur when we've got employers saying we need more graduates and yet we've got graduates who can't get jobs? It's because the mix is wrong. So I started thinking about this, and this is some of the work I've sort of done, is I've started looking at, why is this, I tried to ask myself, why is this happening? What's really the nub of this? Now I don't know if this is the right answer, but this is an answer I'm suggesting may be the case. If we look at the I can't remember what ICSCD stands for now, but you can look it up anyway. It was too long to put in the heading, so I just put ICSCD. We look at the levels of education. Our traditional education system, which I'm coming from, and most of you are coming from, we all start off at primary and lower secondary, and some of us will drop out, but most of us will go on to upper secondary level 3. Some of us will drop out, some of us will go on to vocational college. Some of us will drop out and but others will go on to undergraduate. Some will go on to postgraduate, and just a few will go on to PhD. So we have that shape. It doesn't matter whether it's slightly curved or bowed or whatever. It's basically a distorted triangle shape, yeah? Because we have exams, which kicks people out. I looked at the employment skills requirement for 1951, back in the UK, because this was before I started work on the international. And I looked at the demand for employability. So we had semi-skilled and manual, there were less skilled manual, there were slightly less clerical required, slightly fewer owners and managers, and slightly fewer professionals required by industry in the UK back in the 1950s. I then looked at what's the industrial area employment needs. Unskilled manual workers, semi-skilled, skilled, managerial and entrepreneurial. And that looks like that, let me get this right, that's the entrepreneurial. Let's use that. What's happened then in the changes? Right, replacement of semi-skilled and skilled manual tasks with automation. So all those semi-skilled people, their jobs have shrunk. They're no longer needed. Robots have taken over, computers have taken over for the clerical tasks. Relocation of manufacturing, flying geese model. Doesn't do an awful, we've got lots of high added value manufacturing, but the bulk of manufacturing, mass production, is now done outside the UK. Growth of services and knowledge industries. And the effect of that has been, if you actually look at the employment statistics since 1951, which I did, 2001, is that was that graph that I showed you before, and I plotted on the various censuses levels, and what you can start to see is that the shape of the graph has changed. Whereas it was less there, it's actually got higher here. If you look at the grey, it goes like that. It's no longer a triangle shape. It's more starting to look like a egg-timer shape, a Venturi shape. That's what we've got. That's the shape of the graph. It's no longer a triangle. If we superimpose that, that is what the skills profile should look like for the employment profile. That's what we'd like to produce, a skill profile that matches on to the employment profile. But we don't. We have still got an educational system which is triangular shape, the blue, trying to map on to an employment shape which was hourglass. So what do you end up with? You end up with youth unemployment. All these people here, there's no jobs for them. These people here, no jobs for them. Graduates, no jobs for them. And yet, at the higher level, where we've got a great demand, we haven't got enough, because we've been kicking them off. There's a mismatch between the skills profile, a mismatch between the profile of supply and demand. That, to me, now whether I'm right or not, I don't know. That is what I think might be happening with why we can get skills gaps and graduate unemployment at the same time. Because we've got a mismatch. Our educational system no longer fits the profile for employment needs. That's and as I'm saying, I think we're now in the innovation stage in of the economy in the UK. You're probably coming onto that shortly. So whether this will hit you at some stage in the future or not, I don't know. That's for yourselves to be working out. What is it that you need to be doing at UTP for your Malaysian economy? I would like to work with you on that. I want to work with you on that. But I can't do it for you. You're going to have to work that out. So how would we get that profile? How do we get the skills profile to look like that? Well, we can't do it if we just have this basic nature of every level, we're going to give them exams, and the people who fail, we're going to kick out. You're stuck with a triangular shape. We've got to find a way to accelerate some of these people through who we normally wouldn't think of being good enough to go on. And this is where this employability skills mix can, if we stick to the hard technical, we're going to be stuck with that every percentage a few drop out. If we can think of, right, well, there's a mix of employability and soft skills, we can map the two together and get the hourglass shape. So, we can say the determination of the mix of employment is complex. This is the interface between the world of work. Whether we regard that as this interface between work and education is crucial to getting that shape right. Now, whether we regard that, the interface between employers and education, world of work and the world of education, as a bridge or a gap, is up to us. In the past, a lot of academics, and I know a lot of academics, right, I don't think it's you, because you wouldn't be here listening to this if you were, but I'm sure you know academics who don't want to get involved with the world of work. To them it's dirty, it's not relevant. They're in academia because it's academia, it's pure, it's not dirty, it's not messy. But I'm afraid they consider it as a gap. I consider this interface as being a bridge, something positive rather than a difficulty. And that's this. The world of work, the world of education, is where the crossover is employability skills. So how do we bridge that gap? We look to what's industry done. What has industry done? Going back 50 years ago, most manufactured products were made by a company who said, they did some market research and they said, this is the product we think we should make, we'll produce it on a production line, we'll sell it, put it into our shops, and then people will buy it. It was a push system of manufacturing. Yeah? What's happened? Competition, changing markets has meant that that's no longer sustainable. Manufacturers who relied on push systems of manufacturing went out of business. They were superseded by the Toyotas of this world, who developed pull systems of manufacturing, where the production line still looks the same, but if you go into a car factory, every car going down that production line is different. It's being made to a specific order. Whether they've actually got a sale for it or not doesn't matter, but they're not all looking exactly the same, with exactly the same engine, exactly the same trim. The doors coming through are slightly different. Everything's matched. It's using the internet, using Industry 4 to enable us to have that customized mass production, mass customization. How have they done that? They've listened to the voice of the customer. They've had, listening, what is it the customer wants? They'll make the customer's order. That is, I think, the step change that education has to make. We have to move from a push system of education to a pull system of education. We've got to listen to the voice of the customer. Who is our customer? Is it the students or is it employers? I'm suggesting it actually isn't the students, which is what the system in the UK is saying. Listen to your students, you've got to respond to your students. I think it's got to be the voice of the employers who are going to give these students jobs, employability. At the moment, the traditional HE system pushes people into jobs, and then we rely on the employers making them employable. What I'm suggesting is demand-led HE pulling people into jobs. Now, it's complex, it's difficult. That employability needs hard and soft skills. That's the traditional model. I tried to draw a picture of what does push education looks like. Government decides the syllabus, government gives the funding, government sets the numbers and targets for HE. That's what still was happening until very recently in the UK. HE took that and produced graduates who went into the labour pool, who employers employed, and then fed back to listening to the voice of the employer engagement, was saying, what was it we wanted to learn? We'd listen to them. HE, our own staff would be saying, what is it we wanted to learn? We'd adapt the curriculum. But that was basically the model. That's the push model of education. The priority is efficiency of education. The pull system is a lot more difficult to do a diagram, effectively because everything's superimposed. But government define the context of education. There's always a role for government. They define the context and framework. What's the quality standards? What's the targets? Education starts to produce the graduates, the basic knowledge, the underpinning knowledge that all engineers need, maths, science, analysis skills, some of those sorts of skills, that's all provided. But once we've got past that, then we start to draw in the employers into the world of education. Employers become involved in the latter stages of education to define what it is our graduates. Each graduate is being prepared for a particular role in industry as defined by them and a potential employer. Get the employers to pay for this. They're the ones who are going to benefit from it, certainly in postgrad and in continuing professional development. Education shouldn't stop when people leave university. We know it doesn't. So that's a pull education. Pull education, education programs tailored to individual requirements, concurrent development of hard and soft skills, chunking of programs down into shorter blocks to reduce lead times, where the priority is the effectiveness rather than the efficiency. And so we end up with a model of a mix of push and pull. We've still got a push phase, which gives us the triangular model, but we've now got a pull phase, which gives us a linear model, where we're using it, it's still not quite an hourglass, but it's better than where we were. We've got the pull phase, which is linear, a rectangular shape. So we end up with this active learning. Coming back to finally getting around to active learning. This is active learning, where we think about the learning we are doing. How are we structuring the learning? how we're responding. It's not static, it's active, it's responding all the time. It's a mix of classroom education, work-based learning, and somewhere in the crossover, blended education, blended learning. The traditional model of industry, to make that happen, this is the traditional model, and we've been good at this in Aston. You know, we talk to industry, we identify what they need, they give us some money, sponsor research, knowledge transfer partnerships, and we give them knowledge. That's the traditional model. This is what I'm trying to do with Aston Professional Engineering Centre. Not a bit of a messy diagram, I can't come with any better yet. We've got the university, and part of the university, Aston Professional Engineering Centre, is getting out there into industry. So the communication is happening here. It's more immediate. They haven't got the barriers. The knowledge and the money and knowledge and understanding is a two-way flow. When I go out working with ICE students, I learn as much from them as they learn from me, because I'm out in their industry. That's where the cutting edge is. The cutting edge is rarely in the universities these days. Have we done this? We have done this. I've done this with BP. I didn't know I was doing it when I started it. It's only in the past year that I've realised this is what I've been doing for the past 4 years. BP had a company need, large quantity of high quality engineers needed in various global locations, all over the world. You've all heard of the Gulf of Mexico disaster, yeah? Right? Those engineers weren't bad engineers, but they had stopped thinking about what they were doing. They were doing the same thing over and over. They weren't actually BP engineers, but they were working within the BP context, so we say they're BP. They were working for BP. They just stopped thinking. They weren't doing it. And BP can't let that happen again. I've got engineers all over the world. We've got to make sure they're all raised, their educational level, their professional competence is raised. So they need competence all over the world to do the job effectively, cope with the difficulties that arise, take responsibility, to do the job legally and ethically. They need to be capable. This is competence. Yeah? We've been talking about competence-based education for ages. I'm starting to talk about capability now. Competence is something you can write down, you can define. This is competence. This is what somebody needs to do. That is not capability. Capability is someone who's competent to do a task, but can then take it into a completely new environment where no one's ever thought about it. Are they capable to take their competence and adapt it in a new situation? We want engineers who are going to be capable in the future, but how do we train them to be capable? How do we educate them to be capable? Well, we can't, but we can help them learn. So BP had this problem. They came to the Engineering Council. This is the Engineering Council website about what's called engineering gateways in the UK, which I've been working on with them now since 2006, 2007, about how to learn whilst earning. So you keep learning, either at the end of your degree, or your postgraduate degree, or it's whilst you are doing CPD later on. How can we take education out into the workplace? It was sponsored by our government, all for government. A raised academic standard for chartered engineer to master level had meant there was fewer people becoming chartered. Declining number of students enrolling on engineering courses and fewer universities are teaching engineering. That was happening. That's what was happening. The introduction of student fees resulted in a steady decline in the number of engineers who wanted to become chartered, the equivalent of your PE over here. In the context of an advanced technology economy, and innovation technology, we need more engineers at CEng level, not less, which was what happened. So the Engineering Council and the government got together with some money and came up with this project. So what we want to do is get more people to CEng. You don't have incorporated engineer over here, do you? No, we have these 3 levels. These are for your engineering technicians, these are for your average engineers, if you like, these are for your engineering leaders, your PEs. So we have these 3 levels. The proportion varies from company to company. But all of this structure, this professional engineering structure, is overseen by the Engineering Council, who I was working with. So they set up this project, which I worked with them on, to create MSc Professional Engineering and a BEng Professional Engineering. This would be a 3-year part-time work-based learning programme. This would be a 2-year top-up programme for people who've already got a first degree or a higher national diploma, but want to get incorporated engineer status as well. These would be backed by the Engineering Council, so that we would co-develop both the academic content, the requirements, and the professional competencies required for these professional levels, to try and make it more available to what they were talking about, the widening participation agenda. The first programme started in Kingston in November 2007, who I was working with then. Further programmes were established in Northumbria and Staffordshire during 2008. In that first year we recruited only 50. Well, that was still more than they expected. We got 50. I came and took the programme to Aston in 2010. started with Aston in 2010. We had approximately, and Cardiff, another university, started in 2011. There are now 9 UK universities doing this programme, and with over 200 engineers now enrolled on these programmes. So it's not a huge programme. It's never going to be a mass programme. We're not trying to replace traditional programmes. We're trying to provide a programme for those who can't access the traditional programmes, or for the traditional programmes aren't the most suitable programme, at least at this stage. Maybe 50 years down from now, things will be different. First graduates in 2011, first graduates in 2013 from Aston. The Aston Gateways project for 2010, we have piloted a very high quality MSc professional engineering at Aston. We've developed effective operational practices, which for university to do this sort of work is very difficult. They're doing the vast majority, thousands of engineers every year are doing a taught programme. The systems aren't set up to do something innovative like this. How did we do it? We set up Aston Professional Engineering Centre, which is sort of independent of the departments. I've developed a new learning pedagogy to support this work-based learning. We've launched and successfully operated international cohorts in Angola and Indonesia, so we know we can do it with BP. We've started developing a virtual work-based learning programme using software. That's on go. We've cascaded the learning method into a B-Eng, and we've set up the Aston Professional Engineering Centre. So we've done a lot in 4 years. We've got a long way to go. It's a 2 to 4 year work-based learning. No attendance required at the university at all. All of the learning is done in the workplace whilst they are doing their normal job. University supervisors visit every 3 months. If we don't visit, we use the internet. We use Skype or telepresence or something like that. But there is monthly or even weekly contact using the internet between the engineer. I don't call them students anymore. These are peer engineers. We are learning as much from them as they are learning from us. The academic learning and competence is developed into a single programme. We're looking at both theory and practice at the same time. We're trying to get more bangs for our buck, more beef for our buck. And we do that using this critical and reflective thinking. I'm conscious of the time. How long have I got? 15 minutes, right. So the basis of this programme is mentoring, using critical dialogue. Talking with the engineers about what's it, not telling them what to do, but asking them why they're doing it, developing their thinking skills. These are all engineers already working. They're already competent, they're not necessarily capable. How are we going to go from competence to capability? We're going to develop their thinking skills, going back to what I was starting from, about the thinking skills which are consistent across all disciplines. We're motivating, inspiring and challenging. Regular meetings with a professional supervisor who engages in critical dialogue. Very important, the structure of this. We're not just using it, there's a real structure behind what we're doing when we go and do the critical dialogue. Using structure and mentoring to maximise personal excellence. They coach the art of critical reflection. You can't teach somebody how to critically reflect. You can coach them, you can help them, you can train them, but you can't teach it. You can give a course on critical reflection, but the people who sit on the course won't be critically reflective. They'll know what critical reflection is, but they won't be critically reflective themselves. So this is the model that I've developed, this triple loop or triple mode learning. This is learning by imitation, which is the overwhelming majority of taught courses is learning by imitation. Somebody stands at the front of a class, communicates it, or they give a textbook out and says, read this. The efficiency of learning is how well is that knowledge and understanding, hopefully understanding, but certainly knowledge communicated. That's measured in an exam. So you listen, you watch, you try out, you'll have an exam there, a test, and you decide is somebody that they can do the task, they are competent. But that's learning by listening, learning by imitation. When somebody goes to work, they start to learn by experience. The first time we do something, the first time we always do something here, you know, we're not as good as we'd like to be. We experience disjuncture or cognitive dissonance, to use the jargon. Yeah? It's not what we want. We know we can get better. So we reflect on it. We reflect on it and then we change the way we do it next time. We'll do it a little bit better. We'll try a different mix. We'll try a different approach. And we'll get better. So over time, we gradually get better doing what we've been taught to do. So this is a law of returning, a law of reducing returns, because there's a limit to how good we can get because we're trying to do the same thing. This is what I call incremental reflection. People use the term critical reflection very often and don't define what they mean. This to me is incremental reflection, just thinking about what I've done, how can I do it better? Critical reflection, on the other hand, takes us into the world of learning by reflection or learning by thinking, which is what we want our very best engineers to be doing. Learning not what I know, but learning more than I know. Learning things that I don't know yet. Learning things that nobody knows yet. This is the mode 2 knowledge creation that's happening in industry. So they critically reflect and they ask questions like, why did I do it that way? What were the assumptions? What are the taken for granted? What did I know? What didn't I know? Come up with new theories, new ideas. Generate hopefully some breakthrough understanding, engage in discourse with peers, and then go back to reflecting. So 3 modes of learning. Learning by imitation, experience, or reflection. What's that expression by Confucius? There are 3 ways I can learn. Learning by experience, which is the hardest. Learning by imitation, which is the easiest. And learning by thinking, which is the most valuable. So, having come up with that just a few years ago, I thought I'd cracked it. I then read this quote by Confucius and realised he was there 2,000 years before I even thought about it. So, there's nothing new under the sun, but there's value in that. So, what we're working on in this course is this area, this MSc Professional Engineering. This is what we're trying to do. We're working on this ability to switch the points. Engineers do real projects in work, but instead of just getting better at it, we engage in critical dialogue to get them to practice learning critical reflection, to learn by thinking. So they will create new knowledge and understanding. They will have learned how to learn. So that top quadrant, instead of going incremental, which is thinking about the normal, the knowns, the parts, the facts and the whats, we start asking them questions about what unusual happened, the sorts of things which we would normally discount as being an outlier, and we're not interested in because it's a one-off. No, it's the outliers that really interest us, the things that didn't go the way we expected. What were the unknowns? Remember that slogan by the American general? There are the known knowns, there are the unknown knowns, and then there are the unknown unknowns. Yeah, and he got a lot of stick in the media for that, for sounding silly. No, that's really powerful stuff. It's the unknown unknowns that should be interesting to the innovative and creative engineers of the future. Not the known knowns, we can leave those to the incorporated engineers. It's the unknown unknowns that we're interested in. What are our assumptions? Why are we doing it this way? This is about changing the mental world. That's about changing the... We need to do this. I'm not saying this is bad. This is really fundamentally important to all engineering. It's 90–95% of engineering. But breakthrough engineering, world-class engineering, engineering solving the problems of the future, is this 5%. So I talk about the 5% of engineers I want to do this sort of course. Critical reflection, multi-perspective, probably involving moral and ethical considerations. A systematic reframing of complex problems. You know, can't break it down into parts, because breaking it down into parts is easy, that's analytical, but you ignore the systemic effects. Have you read the book Fifth Discipline? Come across that? Fifth Discipline, Systemic Effects? Something else I've got to talk to you about in your settle about fifth. It's getting on a bit. It's a thick book. It's that thick, but it only really needs to. You only need to do the first 3 chapters, and you've got the essence of it. So, tacit to explicit knowledge. Have you heard of the tacit and explicit? Thinking about thinking, learning about learning, challenging our assumptions, and this is really it. The things we take for granted. We assume them because we've always assumed them. Everyone else has assumed them. We start asking questions about that. And what we're trying to do is to get our engineers, at whatever level they start our courses, we find they are very good at reflective writing. Sorry, the wrong way around. That should be descriptive writing. Sorry, I've made a mistake on my slide here, because I was doing it on the plane. Should have done it well in advance. Don't copy this, I'll change it before I send it. That should be descriptive writing, descriptive reflection, and reflective dialogue, critical reflection. There is a hierarchy, and it takes time to get from here to here. You can't go into one class and suddenly do it. It takes 2–3 years to be able to go from a descriptive writer to a critical reflective engineer. But it can be done, and that maps onto this work by Dreyfus and Dreyfus. If you come across this, the 5 levels, going from a beginner to an expert. This is the talent pipeline. How do we get expert engineers? How do we take people who are just beginning as engineers to become experts as quickly as possible? And this is the hierarchy: beginner, competence, capability, and expert. I've missed out novice because it's a bit confusing. They have 5. I've cut it down to 4 because it's a bit simpler. I don't think novice and beginner really, there's not too much difference between them. Again, a great book to read to get you thinking, not to learn it because I've adapted it, but it's a starting point for thinking. So this is going to accelerate the talent pipeline. This is going to speed up the development of engineers who can cope with Industry 4. Conscious of the time, so I've only got a few more slides. Continuous learning, mentoring and externalization, theory and practice. This is the crossover. This is what I call professional. I call it MSc Professional Engineering because it's more than an academic, it's more than vocational, it's this crossover between the world of work and the world of academic. It's professional. That's what to me is professional. The learning success factors, it works because this is to work by race, wanting to learn, ownership of learning, learning by doing, learning through feedback, making sense. We've covered all those bases in this course. Self-motivation, they come on the course. They don't have to, they've got a job already, they want to. They design their own program, it's learning by doing. We have academic supervisors give them feedback. We have professional supervisors who help them make sense of their learning. We have projects our engineers do typical, these sorts of projects. Really conscious of the time, it's not reading that, this is a picture one. We had an engineer working, this was not a disposal, you know, a rivet when you're putting assemblies together. Well, instead of having a rivet which you have to drill out every time, a rivet which goes in, put it in, pry it, and you're going to offload it again. So it's a rivet that's going to be released and reused over and over again. This engineer was doing this as a project for BAE Systems, reviews the direct metal laser sintering process and identified developments in that to actually produce these parts by direct metal laser sintering. That's cutting edge stuff, and he was doing that in his workshop, in his own small company, 2 engineers working together with one of our supervisors. That's the sort of output that you can get from these projects. Another engineer working for a diesel generator set, they had a complete redesign. They'd put some of these sets out, had gone through all the CAD processes, everything, but in certain circumstances they were getting vibration of the bed plates. So the problem was how to resolve that vibration. What's to do a short-term fix to get the kits out, the sets out there that were vibrating, how to make an immediate repair, and then how to redesign the whole thing for a long-term solution. That was another project. Typical, I missed number 3, but never mind. Analyse and devise a strategy for decommissioning a complex process plant. This was a project for one of our engineers, a massive project. This is, you can get it from BP. Produce a document to assist the design and generation of the design engineer of the next generation of plants. Massive project. This is the sort of projects which our engineers are doing. They're really capable. They couldn't do it. They could do it anyway to a level of competence. What we're doing is working with them from the staff to the university, going out there, working with them to make them capable of doing things they could never have done before on their own. This is why we're accelerating, and this is the model we've now got at Aston. We're working at all levels. We've got the Engineering Academy at level 2, 3, we've got the BEng program level 4, 5 and 6, we've got the MSc at level 7, and I'm just starting to talk about an engineering doctorate at level 8. So finally, these are some of our partners. We've got over 50 of them so far. Some of these names you'll recognise, some not. We're not working with, apart from BP, we're not working any big way. Most of them have got 1 or 2 engineers because these partners are all experimenting with it, finding out what's new about this. They've never come across it before. It's very difficult to do. It's not easy for the engineers. We deliberately make it difficult. It's not easy for the employers because they have to open up to us, and it's not easy for the universities. We have to change the way we work. It changes the way we think about knowledge. What do we mean by knowledge? It's not ours, it's not something we own, it's something that's shared with our engineers. It changes the way we think about ourselves, which is difficult. It sets out very high standards of professionalism, far higher than we get normally, and it changes the traditional professor-student relationship. That's gone. In these sorts of programs, you've got 2 engineers just at different stages of their career. One experienced, one a less experienced. So it's only for those who are not satisfied with the way educational systems separate classroom study from the real world. If your university is satisfied with the system, then we might as well just have a nice cup of tea and chat about the weather or something. We ain't going to go any further on this. Believe that teaching and research are equally important for universities. Research is absolutely fundamental, but teaching as well. Or should we say, I should have used the word empowering learning rather than teaching. I would rather use empowering learning. Are prepared to try something new. Nobody else has done this before. This is new, cutting edge stuff. The Australians have done some work on it, but they haven't gone as far as we have. So I can't say to you, oh yes, we've done this in Thailand, we've done this in Vietnam, it's a dollar, just do it. If you work on me with this, you're going to have problems. We're going to have problems. But we're going to solve them together. Can take on a new global perspective which recognises the interconnectedness of the world. This is why it's so vital for Industry 4, because it recognises working together with partners gives us that global connectedness. In the Industry world, 4 world is no longer distance that separates us. Yeah? Cyber physical systems. If we're separated today, it's only because of our values and our beliefs. And those will persist if we don't talk to each other. Better education for all is a worldwide imperative, and human intellect is the ultimate renewable resource. Right? I believe that. International partnerships between universities are the best way to ensure the development of that resource, and that we were ready for Industry 5, whenever that comes along. I'm sorry to take up nearly an hour and a half of your time, but I hope, if I haven't done anything else, I've made you think about some interesting developments in a slightly different way. Thank you very much. There was 84 slides there. I knew it was too much, but I didn't know what to cut out. I thought, what can I cut out? I get one shot at talking to you. I'm going to try and pack as much in as possible. We're not going to be able to come back next week and do it again. If I can't hook you now, I'll never hook you. Okay, so please forgive me.
I'm sorry about the internet connection.
That's all right.
Lovely videos to show us. Okay. Can I open the floor for questions for Bill?
Yeah, Prof. Bill. How different is your active learning with the, what is called, lifelong learning?
They can be the same. You can do lifelong learning in an active way, or you can do it in a traditional way. You can go and do a distance learning course with the Open University or something like that, where you will study the material, you will sit an exam or a test, and you will learn in a traditional, what I call, transmissional way, transmitting knowledge and information from a knowledge artifact to another person, just transmitting it. Or you can do it the transformational way, which is the active learning, where you work with our engineers so they no longer just learn they learn from themselves. They've learned how to learn for themselves. And that's what we're trying to do with active learning, is getting engineers to learn how to learn for themselves, not just to us. That's the difference between transmissional learning, which is the traditional model, and transformational model, which is the active learning.
Actually, we have a program which is quite similar to what you were explaining.
Yeah.
MBA Energy Management,
Where
where we have candidates or students from in the industry.
Yeah.
They are working, and in that program we have one capstone project, we call it, where the student will find some case study, and the supervisor, we have a supervisor from the university as well as supervisor from the industry, where we merge the three to discuss about the project and come up with some solution.
That sounds like it, yeah. That's it. That's sort of putting your toe in the water and doing it, yeah.
Yeah, we have some process before they carry out the capstone project.
Yeah. That's it. So you've got some experience. It's one of the reasons I think that when I came first to talk to people here about it, there was interest, because you've already had some experience. But as you say, it's an MBA for business. It's not for engineering. It's for a single. It's not across. I mean, I've done the whole way. I've done the whole hog. The whole course.
But the students are mostly engineers.
Yeah. Are they on the MBA?
Yeah.
Oh, right. So I didn't know that. I just knew it was an MBA course. Well, that's good. So you've got a lot of experience, because this model that I've developed.
Actually, we are just started.
Sorry?
We are just started.
Just started it. That's great. That's great. But you've started thinking about it, and you've bought into that model already.
Sure.
See, I understand that what I've developed was based very much for the UK model from a Western perspective. And that is not a global perspective, as much as I try. The only way we can ever come up with a globally valid course is by talking to people elsewhere and saying, well, what's the context for you in this part of the world, be it Africa, ASEAN, South America, or whatever, and then adapting what we've done together, working together in partners, and not saying, well, I'm going to run your course, and you're going to run mine, or we're going to compromise a bit of yours. No, let's sit down, get our heads together, and talk about what's best for global engineers of the future, and come up with a solution based on your experience and our experience, and people in China and Brazil as well. So I mean, that's what I'm really looking forward to, the dialogue, discussion, and the fact you started it is excellent.
We hope we can improvise the process further as time goes on.
Yeah, this is action learning, it's action research in a sense, because you know we're doing it, and we're what I've got now is nothing like what I started off with 5 years. Well, it is like it. It's changed in lots of ways, because as I've gone along, I've made mistakes and I've changed things, and no doubt you'll do the same. And if we share that knowledge through some form of network, then I'll learn from your mistakes, you'll learn from my mistakes, and that will shrink the development time, won't it? Yeah. Fantastic.
Right. Any other questions?
Have I shell-shocked you all into silence? Was there too much?
Or an observation maybe no question, maybe an observation.
Yeah. Well, listen, if any of you feel that now is not the right time to ask, but you want to reflect on what I said, reflection, critical reflection, not just incremental reflection, if you would like to reflect on that and drop me, I really would. I'm not saying this just as any sort of tip would say, oh yes, I really mean it, because the only way I will make this program better is by talking to other people about what it is you're doing and how we can enhance it for delivery here, which is what I really want to do, is work with your university to work on a course for. Oh, right. I didn't bring it up. I've got some in my bag, I think. So, there you are. That's the penalty for sitting at the back. I've got.
Okay, so if there's nothing further, maybe we can close the session. I would like to thank Will. Let's give him a round of applause. It's a very enlightening session, Will. Thank you very much. We look forward to working closely with you.
So do I.
Right, and we have the head of the Center for Excellence in Teaching and Learning, Tazli. So I would like to call upon Tazli to present Will with a token of appreciation from all of us at CETAL and UTP.
Thank you very much. I much appreciate it.